where we stopped on the last one, solving these trigonometric functions. So with these here, and luckily this is a nice one to stop on. So when solving these trigonometric equations, if there's only one trigonometric expression, we just need to get it by itself and solve from there. If there's more than one, we need to make sure they're all the same. So here we have sine squared sine and a number. So all of our trigonometric functions are in terms of sine, which is good. Because if it's not, we need to be able to get it into either all in sine, all in cosine, tangent, secant, cosecant, cotangent for us to be able to solve. Now for this one here, we're going to be able to factor this here. 2 sine squared minus 3 sine of x plus 1 is equal to 0. So the first thing we would look for is a greatest common factor between our three terms. 2, 3, 1, there is not a common number that goes into all three, and sine is not one either. So we'll have our two sets of parentheses with three spaces. If the third term is positive, then the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Well, here the third term is positive, so the signs are the same and match the sign of the middle term, which would be negative and negative. Now we need to find the factors of the first and third term. Actually, out of the two, the third term is the easier one to find because it's factors of 1, which are 1 and 1. Now we need to find the factors of 2 sine squared of x. Well, sine squared of x is going to be sine of x and sine of x. That's the only way we can multiply sine by itself and get sine squared that will work for this here. And the last thing we need to find the factors of is 2. Well, that would be 1 and 2. So we just need to stick 2 in front of one of the signs. Now we can check and make sure that we do get the middle term of negative 3 sine of x. Well, 2 sine of x times negative 1 is negative 2 sine of x. Negative 1 times sine of x is negative sine of x, which does indeed give us negative 3 sine of x. So all that does tell us is that these are our two factors. Questions on this here. Now at this point, since we have two things multiplied together to equal 0, one of these has to equal 0. So we either have that 2 sine of x minus 1 is equal to 0, or sine of x minus 1 is 0. Now for the one on the left, we need to solve for sine of x. So the first thing we can do is add 1 to both sides, telling us that 2 sine of x is equal to 1. Then we would divide both sides by 2, telling us that sine of x is equal to 1/2. Now at this point here, I would pull the unit circle out. I think I need to run more copies of those off because I don't know if everybody still has their unit circle. Because the unit circle is nice at this point because we're looking for what value of x will make sine be 1/2. And on the unit circle for sine, we're looking at the y values. And the first one that has 1/2 is pi over 6. If we go around the circle, the next one is 5 pi over 6. Questions on this here? I think you all need unit circles again. Yeah. Look for it. If you don't have it, let me know because I can get you another copy. Because especially for these here, it's nice to find these because using sine inverse, as we can grab the calculator again, there we go. It's in radians. I can say sine inverse of 1/2, which does tell us pi over 6, but it doesn't give us the other angle. It doesn't give us the other angle that would give us this pi, this 1/2 for sine. The nice thing about the unit circle is it'll tell us if we don't have to use reference angles and know that the other value for sine, that's 1/2, is in the second quadrant. Use the reference angle of pi over 6 and go from there. But these here are two of our solutions. Questions on how we got these here? Now the other one we have to solve for is sine of x minus 1 equals 0. First thing we can do is add 1. Telling us that sine of x is equal to 1. Now most values for sine, especially ones that are going to be on the unit circle, have two different spots because sine's positive in the first and second. It's negative in the third and fourth. Now sine of x equals 1 at pi over 2. There's only one spot that is going to be 1. Because the other spot is actually not positive 1, but negative 1, 3 pi over 2. So pi over 2 is the only angle that works for this here. Now, one other thing, it did tell us that the interval is 0 to 2 pi, because all that means is that we're just looking between 0 and 2 pi. We don't want every angle that will make sine be 1/2 and every angle that will make sine be 1, because we can get the coterminal angles. We can add 2 pi to it. Because pi over 2 plus 2 pi over 2 plus 2 pi. So 5 pi over 2 would also make it be 1, or any of the other coterminal angles. But since it just wants it between 0 and 2 pi, we don't have to add those. We don't have to add the 2 pi in. These three here are our three solutions. Questions on this here? Are you ready for the next one? 3 secant squared of x minus 2 tangent squared of x minus 4 is equal to 0 on the interval of 0 to 2 pi. Now this one here, we do have to use the reference sheet because we do not have it all in terms of secant or tangent. We need it in one or the other. Excuse me. Now since it is secant squared minus tangent squared, make sure I didn't write this in correctly. Because secant squared minus tangent squared, it doesn't matter which one we convert it to. Secant squared minus tangent squared. So it doesn't matter how we change this. And the reason I say that is because we're going to be using our trigonometric, our Pythagorean identity. Because we have that tangent squared plus 1 is equal to secant squared. Or we have that secant squared is equal to tangent squared plus 1. So no matter how we want to convert this, we can use either one. Well, we can convert this all to tangent. So our secant squared here, we can replace with our tangent squared plus 1, which will tell us that we have 3 times tangent squared of x plus 1 minus 2 tangent squared of x minus 4. Because we could have replaced the tangent or the secant. We had to pick one or the other. Because I either need it all in terms of tangent or all in terms of secant. Now with this here, we can start simplifying. First thing we can do is distribute the 3. 3 times tangent squared is 3 tangent squared of x. 3 times 1 is going to be plus 3. Minus 2 tangent squared of x minus 4 is equal to 0. Now we do have some like terms. Our 3 tangent squared and negative 2 tangent squared. Well, 3 tangent squared minus 2 tangent squared is just going to be tangent squared of x. 3 minus 4 is minus 1 is equal to 0. Questions on how we got to this point here? Questions on anything we've done so far? All right. Now we just need to solve from here. Now, since there is no middle term, we can still factor it, or we can use the square root method. Square root method says we don't have a middle term, so in this case, just tangent. But we can get tangent squared by itself, and we can do that by adding 1 to both sides. And that tells me that tangent squared of x is equal to 1. At this point here, we can take square root of both sides, because our square root and square would cancel, telling me the tangent of x is equal to plus or minus the square root of 1, which is 1. Questions on how we got to this point here? Now, it's really telling us two things. It's telling us that our tangent of x is equal to 1, and that tangent of x is equal to negative 1. We have two different cases. Now, tangent is not necessarily or technically written on the unit circle, because the unit circle is only given to us in terms of sine and cosine. But tangent is sine over cosine. And if we go about this way here, sine over cosine. So whatever value angle, or angle, if we plugged into sine over cosine, should give us what? 1. The only way we can get 1 from dividing two things is if the value of both of those things is the same. Because if we divide anything by itself, it reduces to 1. Yes? Where on the unit circle are sine and cosine the same? Not so much their sign, but just have the same value. Well, the first spot is pi over 4. Because at pi over 4, sine and cosine are both square root 2 over 2. Yes? And they're both positive. So tangent is going to be positive 1. The next one's at 3 pi over 4. Cosine there is negative, sine is positive, so it's going to make tangent be negative 1. The next one is at 5 pi over 4. And since they're both negative, it's going to make it be positive. And the last one is 7 pi over 4. The also way we can get at that is tangent of theta equals 1 at pi over 4, because we have it on the back of our unit circle. So we find our pi over 4 values that have a positive or negative tangent. We end up getting these here, because pi over 4 is our reference angle, so for the first quadrant where tangent is positive, we'd have pi over 4. Third quadrant, is where tangent is also positive. We have a reference angle of pi over 4. So to find the exact angle that we're starting with, is we add pi over 4 to pi, giving us our 5 pi over 4, because we can use the reference angles to get there. Because that pi over 4 is the reference angle, So we added to pi to get it to unit, or our quadrant 3, giving us that there. Questions? Yes. Yes. Questions on how we got this here? Okay. Let's look at the next one. Cosine of x plus 1 is equal to sine of x. Now, for us to be able to solve this here, we need this all in terms of sine or all in terms of cosine. And since we do have sine and cosine, our Pythagorean identity says that cosine squared plus sine squared is equal to 1. That's just the Pythagorean identity, yes? So do we have sine squared or cosine squared in our formula, or in our equation here? No. Because we need it to be squared. We need one of them to be squared for us to be able to replace one with the other, yes? We don't have it. So what we have to do to be able to solve this is we're going to square both sides so that we do get this sine squared cosine squared. Now with this here, we do have to be careful, especially with our solutions, because there's a good chance we will have some extraneous solutions show up. Now the left-hand side, really what we're saying is we're taking cosine of x plus 1 and multiplying it by its self. And the reason I'm really rewriting this out, we're having to write this back out, is not so much, it's a little bit of how it's set up, it's this plus 1. Because we can't just times it by itself and just square both terms and be done. We actually have to multiply it all the way out. Because our cosine of x times cosine of x is, cosine squared of x. Cosine of x times 1 is plus 1 cosine of x. 1 times cosine of x is plus cosine of x. And lastly, 1 times 1 is 1. Questions on how we did that there? Now the other side's a little bit nicer. We can just say that sine of x squared is sine squared of x. Because if we did it the same way, we're going to multiply sine of x by sine of x. Well, how many terms do we have there in each one? Just one. We just have sine of x times sine of x, which is sine squared of x. So we could have almost just squared that one term and been done. And the big difference between the two is that our sine of x is just the one term. We don't have anything added to it or subtracted from it. So we just have that there. Now the other side, we do have some like terms. Our cosine of x and cosine of x giving us 2. Cosine of x plus 1 is equal to sine squared of x. Questions on how we got to this point here? Now at this point here, we need to get this all in terms of sine or cosine, because those are our two options. Well, not really, but yes. Because we could rewrite it in terms of sine. We could switch the cosine squared of x here and use our Pythagorean identity and get it in terms of sine, but that's not going to help because of this middle term here, this cosine of x. Because even if we did switch the cosine squared to sine, we still have it in terms of sine and cosine. It's not all the same. So the better option for us is to rewrite sine squared as cosine squared. And we can do that by taking our formula here and using one of its other forms, which is telling us that sine squared of x is equal to 1 minus cosine squared of x. And we get that from subtracting cosine squared from both sides. So that means our left hand, or the right hand side, is now going to be 1 minus cosine squared of x. The left hand side is going to be the same. Questions on how we got to this point here? Now we need to get this thing equal to 0. So one of the first things we can do is subtract 1 from both sides, because our 1 minus 1 here will cancel. It works out on the other side. It also cancels. And we can also add cosine squared of x to both sides, telling us that we have 2 cosine squared of x plus 2 cosine of x is equal to 0. Questions on this here so far? Now we can solve this by factoring. Always first step, is there a greatest common factor between our terms? Well, both of these have something in common. So we have 2 and cosine of x, because 2 is cosine squared, 2 cosine, they both have the 2 in common, yes? And they actually both have a cosine. Because the first one has 2 of them, the second one has 1. Because I can take cosine out of both terms, and I can take 2. Because if I factor the 2 out of 2 cosine squared, it becomes 1. If I factor cosine out of cosine squared, we're left with cosine of x. Plus, if we factor the 2 cosine out of 2 cosine, we have 1. It's equal to 0. Questions on this here? Now we have 2 things multiplied together to equal 0, so one of them has to be 0. So one of ours is cosine of x plus 1 is equal to 0. The other is our 2 cosine of x is equal to 0, yes? Really, we don't even need to write 2 cosine of x. Because what are the 2 and cosine of x doing? What is our operation? We're doing what with them? They're being, yeah, they're being multiplied together, yes? Because we're multiplying the 2 and cosine of x, yes? Now it seems odd I'm bringing it up because normally, again, we would do this, say 2 cosine of x equals 0, cosine of x plus 1 is equal to 0, and solve, yes? Well, how did we split it up? We said if 2 things multiply together to equal 0, one of them has to be 0, yes? Well, we said we have 2 times cosine is equal to, is there anything I can do to make that 2 be 0? No, it's 2. It's a number, yes? So what's the only thing in this statement here that could possibly be 0? So instead of saying 2 cosine of x, I could just say what? Cosine of x is equal to 0, yeah. Now if we left the 2, and this is what we would normally do, is we just say we divide both sides by 2. 2 cosine of x divided by 2 is cosine of x. 0 divided by 2 is, we get to the exact same place. Now at this point here, again, we can look at the unit circle and see What values of x makes cosine be 0? One of them is pi over 2. The other is 3 pi over 2, because we're just looking at the unit circle straight up. Cosine 0 straight down, cosine is 0. Now for our cosine of x plus 1 equals 0, we do need to do some solving here. First thing we can do is subtract 1 from both sides, telling me that cosine of x is equal to negative 1. And the one place where cosine of x is equal to negative 1 is when x is pi. Our angle is pi. You do not have to rewrite this back out. I'm just writing it out to the side so that we have our answers and it next to each other. Because especially when we square both sides, we need to check our solutions and make sure they work. And the first one we can check is pi over 2. So we can say cosine of pi over 2 plus 1 is equal to sine of pi over 2. Now we can do this in the calculator or by hand, either one. Cosine of pi over 2 plus 1 is 1. Sine of pi over 2 is 1. So what that tells us is that 1 is equal to 1. So that works. So that tells us that pi over 2 works. Then we can move on to the next one. Cosine of pi over 2 plus, or not pi over 3 pi over 2 plus 1 is equal to sine of 3 pi over 2. Cosine 3 pi over 2 plus 1 is, 2 plus 1 is 1 again. Sine 3 pi over 2 is negative 1. So what we're saying for this here is that 1 is equal to negative 1. Is that a true statement? No. So that means our 3 pi over 2 is not a solution. Now the reason we got it is because our first step was to square both sides. And for this here, we had 1 equals 1. If we squared it, it would have made them both positive. So it does work after we squared it. But in the original solution, our 3 pi over 2 does not give us the correct answer. And the last one to check is pi. So cosine of pi plus 1 is equal to sine of pi. So sine of pi is 0. Cosine of pi plus 1 is also 0. So here, even though we did get 3 solutions, only 2 of them worked in the original equation. The third one was our extraneous solution. And that's it. We'll finish this one tomorrow.